Earth is made up of a vast collage of different ecosystems, from dense forests and dusty deserts to icy tundra and temperate grasslands, and everything in between. In the scientific community, we define ecosystems as groupings of organisms which live in tandem with their physical environment. Within an ecosystem, living organisms such as plants and animals interact with the non-living components of their surroundings, like the air they breathe, the soil they dig their roots into, and the minerals they absorb in order to grow buff and strong. The exchange of nutrients between organisms and their surrounding environments is one of the foundational functions of Earth's various ecosystems. Nutrients are elements, such as carbon, nitrogen, or phosphorus, that aid in the growth, maintenance, and reproduction of living organisms. The supply of available nutrients within an ecosystem is limited. Therefore, in order to account for their relative scarcity, nutrients are continuously recycled through the rotation of chemical elements between different nutrient pools. In the world of science, we call this exchange nutrient cycling. In the context of this video, we will focus our attention on one offshoot of nutrient cycling, the carbon cycle. Carbon is one of the Earth's most important and widely variable elements. Because carbon is a vital component of all organic molecules, living organisms require carbon in order to live, grow, and reproduce. The carbon cycle starts in the atmosphere, where gases, such as carbon dioxide and methane, accumulate around Earth's surface. Through the process of photosynthesis, carbon dioxide is removed from the atmosphere and converted into nutritional glucose, the primary food source of most plant species. Following photosynthesis, plants accumulate stores of carbon in the form of glucose. This aids in the growth and reproduction of vegetation. Eventually, however, plant species wither up and die, leaving behind stores of carbon in the form of discarded litter. This plant litter can break down, resulting in the buildup of carbon in soil. Ultimately, however, carbon returns back to the atmosphere through the process of respiration, which releases carbon dioxide back into the air and brings the end of the carbon cycle. Environmental factors can exert a strong effect on the chemical balance and organismal exchanges of an ecosystem. When the environmental factors deviate away from their norm, such factors in the environment can disrupt the delicate balance of a local ecosystem. Often these shifts are promoted by disturbances. We define a disturbance as an event in time that upsets an ecosystem, causing changes in the resources, substrate availability, and/or the physical environment of a local community. In our discussion, we will focus specifically on the role fire plays as a disturbance within ecosystems and their communities. Fire is often viewed as a destructive force. It tears its way through vegetation, burning everything that dares disrupt its path into a powdery black crisp. It destroys life, damages communities, and threatens safety. Fires, however, can also be a positive disturbance. Take, for example, the community of the tallgrass prairie. Tallgrass prairies, localized primarily in the central region of North America, are characterized by frequent stretches of fire, which help to balance and moderate vegetation across the prairie's local landscape. According to a set of prior studies, fire can help local species overcome the competitive effects of foreign invaders by creating wide, open spaces for the colonization of seedlings, and also by altering the physical environment of the prairie. Fire, in turn, can help to maintain the natural conditions of the tallgrass prairie and optimize the diversity of plant species found in their native environment. Fire, additionally, can help to monitor the cycle of nutrients throughout an ecosystem, leading to healthier overall plants. In order to put this theory to the test, a group of students from Grinnell College headed straight to the restored prairies of central Iowa. There, they compared the growth patterns and physical characteristics of unburned versus burned patches of the local tallgrass prairie. Students tested the temperature and moisture levels of the soil, the organic matter content of the soil, levels of above ground and below ground biomass, and rates of respiration. Ultimately, the data collected by students at Grinnell provides valuable insight into the role fire plays as a disturbance within the Iowa tallgrass prairie. First and foremost, students found that the burn plots possessed increased levels of plant density. This finding indicates that fire helps to encourage plant growth and may lead to increased concentrations of vegetation within the prairie ecosystem. Fire, in turn, disrupts the normal flow of the carbon cycle by augmenting the growth patterns of vegetation. Ultimately, however, by increasing plant growth, fire may help to regulate the number and diversity of plant species that call the Iowa tallgrass prairie their home. Students also found that burn plots had less plant matter available to shade their soil, and therefore had higher average soil temperatures. Variation in soil temperature may influence the performance of organisms, and in turn may alter the cycle of nutrients through the ecosystem by either aiding or decreasing rates of vegetation growth and plant litter formation. On the flip side, unburned plots possessed higher levels of above-ground biomass, necromass, and soil organic matter than their burned counterparts. Such findings further confirm the influence fire has on the cycle of nutrients through the Iowa tallgrass prairie ecosystem. At the end of the day, the results of this study illustrate the multitude of ways that fire can interfere with the cycle of nutrients within the prairie ecosystem. As a disturbance, fire modifies the distribution of carbon within the atmosphere, vegetation, soil, and plant litter. However, unlike some disturbances, the effect of fire is not entirely negative. Rather, as the findings of this study have shown, fire can actually help to encourage plant growth by creating more space for colonization and by changing the physical characteristics of the plant's surrounding environment. As scientists, as students, and above all else as human beings, it is important for us to think about the way we interact with our environment and how different forces alter the cycle of nutrients through Earth's ecosystems. Earth and its diverse community of organisms rely on a delicate balance of resources. As an inhabitant of this planet we call home, consider using the techniques discussed in this video as a starting point for your own ecological discussions. How do you influence the Earth and its wide range of ecosystems? And what can you do about it?